I'm close to finishing the setup, but anyways, before a little introduction on the topic of game engines in general. So, if anybody wants to read a bit, then I have two little books. This is the introduction to game engine development, essentially. Pass it around if you want. Don't kill anybody with them. Anyways, so probably the question is on there. Well, when we are building an engine, there are some principal things that usually are like in the engine. So that we get some input somewhere, we have some representation of our game world or the simulation. Then we have something that renders this simulation or the world, and then we have something that moves the world one step further. And additionally, we have loading data, sound, network, some debugging tools, and editor, some way. Like the last 5 are pretty much optional if you don't want to get it into details, but usually when somebody says game engine, they for some reason think this. I don't expect you can read this at this point, which is kind of lots of stuff. Lots of stuff. You have kind of some game specific stuff. You have cameras, you have like displays and kind of particle effects, animations, networking, and then you have like more stuff and even more stuff. We're not going to implement all of this today, but why would you want to implement a game engine at all? So the number one reason is for not implement game engine is you want to make a game. This is the worst reason you have for making an engine. But there are plenty of other reasons. You want to learn stuff, you want to understand what the other game engines are doing and how they were built, what were the trade-offs involved, and how they kind of merge together in a like complex stuff, ball of mud essentially. You want to have some fun with your own limitations in designing complex systems, and occasionally you get into that. When you have done all of these, like the 8 steps of other reasons why you want to make a game engine, then you might eventually reach that you want to innovate on the game engine, architecture, whatever, performance, visualization, or just general improvements. So how do you make one? It's pretty easy. You read a bunch of stuff. Well, actually, this reading isn't necessary. You can get it done much simpler. So, has anyone heard of the term spiking? Okay. Spiking is essentially you throw some code at the screen, so it kind of runs. That's essentially spike. So you can imagine that it runs at least. It doesn't have to run. And then you kind of formalize those 2-3 things, and then you clean it up. And then you repeat it 10 times. So we are going to do like 4 iterations today, I hope. So how do you make a triple A engine? So you just do it a lot more, the same steps. There's here is the reading part helpful as well, because there's kind of tons of stuff that you could be doing. I'm going to be coding most of the time. I'm trying to explain what I'm doing, and you are free to ask any question you want. And I'm not going to implement everything. I'm going to leave out sound, networking, mostly graphics, because I will be giving a talk on sound in the future, maybe networking eventually, next year. And visuals programming is one of those other things I will be talking about, and Raimond can give you a whole course on it as well. So I'm going to leave lots of stuff out, because otherwise you wouldn't have anything to do on your own. So let's do it. Let's see whether I can get this one running. No, that's the wrong place. So as I assume you have all kind of downloaded the repository and ran this program here. What this program does is that it allows you to write stuff without having to you can save and just it will update. This is one of the first lessons, is get your feedback cycle as fast as possible. If you are constantly pressing refresh or build, then you are slowing yourself down and kind of so, and I wanted to draw as well. So in terms of huge complex systems, the first step is breaking it down into manageable chunks, because we cannot do everything at once. So let's say this is everything I want to do. So our goal is to take the shortest path to here, and ignoring that we messed up here along the way. So this is the spiking that we put up some waypoints, so we can generally understand what is going on in the system. Any thoughts what might those first steps be in a game? Game engine? Ideas?
Render a thing.
What?
Render a thing.
Yes, rendering a thing is a really good start. I already started the rendering thing because it's a bit annoying to set up in browsers, so yeah, you have this thing. And the next thing is probably then just making it move, because then we have something that we can see and we can tweak. So I'm going to do this. No, this is the wrong language. Okay. So we are going to make it move. No. And we can get this time from here. I don't know. Let's do it this way. So we can say, I don't know. Let's do this. Okay, we have something moving. Obviously, we want to clear the screen and get this something to actually see what is the current state, because when we don't clear the screen, we just end up messing up our canvas. So now that we have something moving, this almost looks like a game already. Oh, one of the things I implemented here is the arrow, because then I can show easily vectors and stuff on the screen. This is one of those things that I have implemented before. Okay. So now to actually make it a game, we need some representation of a world or something. So the first kind of spike is just to say that we have something there, we have something there, at coordinates 10, 10. And then we are going to just increment it 1 pixel every time. So we can, let's say, do this. So this is kind of cool visuals already, like really awesome. So what's the next step? What's important in a game? So we can think of this as like, okay, we have something on the screen moving. We probably want to move it ourselves. So I'm going to do this. Let's do it this way. And we need that as well eventually. So we do something like this, that when we press the button, we move it. So you can see when I click those buttons, I can move it. So we have kind of the general idea how things should move. So now that we have like implemented about 2-3 things, now it's the time to clean up. First thing I probably would want to do is that, oh yeah, this looks pretty bad in terms of updating the state, because I want to update the state in the main loop or the main handling. So what I can do is let's make a keyboard and say that we instead track here the up and down events. So we know when it's pressed and when it's not pressed. Should be this one. Because I don't know what actually the key codes are, from the top of my head, I'm going to do this. I'm going to peek into the event actually. So up is 38. I know I want like these 3 keys, maybe one more later. So I'm going to up, left, down, right. So it's 37. Right is then 39 and 40. And what this allows me to do now is to say that. Oh yeah. So I can now here use it to say that if keyboard up, then I shall like do this. Anybody confused it, or this seems trivial? I think. No. Why didn't you warn me? Why didn't you warn me that I made a mistake? So now I can move around that thing on the screen with my arrow keys. Okay, so effectively now we have an abstraction for input. If we want, we can make it actually a little bit cleaner, that we had here method to say that, oh yeah, it's return this. So we can say, instead of indexing into a map, we can do rest like this, and it will still work. Okay. Now the next bit of cleanup is this part here. Because we have a world. Is the code big enough? Jorma, is the code big enough?
I'm just not wearing my glasses.
Okay.
Don't worry about it.
Okay. I won't. So that we have here these free floating variables, we want to actually kind of encapsulate and group them, because when we group them, they get a bit neater and they get a bit like more tighter in their representation. So we can do here this abstraction this, and then when we are here, we can do this. And obviously I'm constantly checking that my code still runs, so I can otherwise when I start to make really big leaps in my code, then I cannot follow all the design decisions that I've made. The more design decisions I make at the same time, the more likely is that I miss something and the more mistakes I will make. What? Okay. So, and now instead of having this thing here, I would like to actually put it into the player, because the player is the one actually moving around. So let's move it here. Let's do player update. And this. And also this thing here is the drawing of the player in some form. I'm going to, for now, replace this with something more static. No, it broke. And why did it break? Row 41. Oh. Okay. And I want to do the player render here. And this is part of it as well. And let's and we still have this movement here. Any questions? You can ask me. So while I do these things. Now, one of those things is that here in render we are referencing some global variable that we want to get rid of. So instead of like referencing the global thing, we just pass it in here as a parameter. And for the update, now we have this point where we want to actually start simulating actual physics. This means that we probably need some notion of how much the frame has progressed. So when we take, let's take a new empty drawing. What's the background? So never mind. Okay. So when we have this some simulation, there's this inherent time step that we simulate. So when we show two frames in sequence, there's this, okay, we render one frame, then we update the state, player moves some amount of pixels, and then we'll render the new state. So this time here, how much it takes to move from one state to another, is usually called delta time. And this is, yeah, depending on your engine, like different ways of setting it up. But we are going to set it up as, let's say, this way. We're going to pass in this delta time. So no, something went wrong. It's 1.0. So it's 30 frames per second effectively. But now you see that it's kind of moves really slowly. So we have to have some notion of speed. So we can speed up this character. Let's say speed, I don't know, what is it? Let's say 30 pixels per second. And then we can update this speed times. And now we can kind of move a bit faster. Does this make sense? Okay.
Question. So
Yeah.
doesn't the set interval get called like not sooner than this 33, but it would be larger as well?
Yes,
So
I don't care. This is the part where we are going to, actually the proper way is to call the request animation frame. But we are going to make tons of mistakes and later correct them. Because every time we put into our head a minor detail that maybe like has no significant impact in the engine, we are like reducing our cognitive abilities to think about the big problems and general architecture. So we have this inherent memory limit to ourselves. So we need to focus on things that give the biggest impact. Yes? Do you want to start it or?
No?
Something is running in background. I think. Oh yeah.
Okay. So yes, we will come back to it. There's tons of things that are wrong here, and that's fine. The important thing is that the main flow works. Because we can always, as long as we don't make major mistakes along the way, then we can always fix the minor ones. They might be somewhat annoying, but we can fix them. Okay? So the order actually depends on the person and what do you think is important in the engine at all. Okay, let's fix it for now. And yeah. If you bring it to my attention, I can fix it right away. So instead of saying that our interval is stuck here, we are going to separate the game loop to here. And this means that we now need to somehow figure out what the delta t is here. So we can initially do this, so we don't it's still running, and well, and then we need this function that's Requestanimationframe, which gets called when the browser renders a frame in the browser. What we need to do here is first call the loop with some number, and then we also need to actually start this and recall this function, because every time we need to, after rendering the frame, we need to recall it to start rendering again. So I'm going to call this animation loop here, and I'm going to call it here this way, and I'm going to bootstrap it this way. And it broke. Because when I call the animation loop here first time, then I don't have the keyboard yet set up. This means that I need to move this keyboard definition somewhere upwards. And I have still working, and better yet, maybe let's do this. No, where did it go? Oh, okay. I'm going to completely pull out the keyboard code and separate into a file. So effectively we have created our first reusable part in our engine, a keyboard, which is 12 lines of code. Tremendous reuse. And now we can make a node package from it as well, if we want to. Anyways, we have it working still. And now we need to, yes, something still.
mingi paar on kuskilt lahti. Pane kõik aknad kinni, mis ei ole olemas.
Siis
ei, noh, mis ei ole sinu oma, pane kõik kinni.
This one, so. Okay. Okay, now that we have this basic animation loop, we need to figure out what's the delta time. So instead of like guessing here, we can do instead that we have this, what was the last time we rendered? So we have last time, let's say, this is just shorthand how to do it. And here we figure out what's the current time. And then we can just do this last time minus current, nope, the other way around. Current time minus last time. And then we can update the last time to current. So this gives our basic update loop. No, but it broke something. Because, we don't need this here. And I want to see, because currently the problem is that when I click somewhere, it just blows up. And what I can see here is that here the times are now in milliseconds, which kind of, I like my numbers in seconds, because it's kind of somewhat nicer to work with. So, because I can reason about how I want to move it to 10 pixels per second rather than 10 pixels per millisecond or something. Now we have this thing that's moving. So what we might want to do here is to add physics. So for physics, we need something we need to track how fast the player is going. So instead of moving the player here directly, we are going to update the speed, and from that we shall update the position. So here let's do how much? Who pressed caps lock? And here the integration step is to update with the speed multiplied by our velocity then. And we probably, one of the things that might happen now is that it never comes to a stop. So it starts moving on its own, and it's kind of like weird behavior here. We want it to like eventually slow down, right? So this is also useful because often with imprecise calculations, we might accidentally start accumulating energy in the system, so it eventually kind of blows up. So we usually want to have some dampening numbers somewhere. So this looks a bit cool.
Does the time difference multiplication have to be in both the velocity change and also in the coordinate change?
It works both ways. It's the question of in what units is the speed here. So when we do dimensional analysis, we can say that those our time is in seconds. Is in seconds, then our velocity is in meters per second. So, like deriving from here is to say then that this speed is then must be in meters s squared essentially, which is effectively it's actually an acceleration, but as I mentioned, we can screw things up and it still works. This is one of those useful ways of figuring out how you should multiply things together to get the right answer. So because I know, I want to get speed in return and I have acceleration, this means that when I multiply this with s, I get meters per second, which is the answer I want. So usually it's like speed times time and maybe some multiplier, but who cares? Anyways, so we have movement, and we probably want to now show that we are moving somehow as well. So what we might do is instead of showing here random position or the random direction for the arrow, we might want to do here, let's say this plus let's draw the arrow in the direction the velocity is pointing, which is kind of, so now we can see some more interesting movement. Yes?
Does the dampening also have to be dependent on the time?
Yes, but it's somewhat complicated, more complicated, because now you're multiplying here. But this means that usually you have to use, what was it? You raise it to the power of time delta. Because then it, when you integrate it, it gets the same result as you would additively do it. So I hope I got the order right here. But usually for the dampening, because the numbers, like, it doesn't make a big difference unless you are like skipping frames and kind of messing up things in general, or moving the time step simulation. So let's do something like this. Okay, so now it's the clean up phase again.
I still have a question. So
Yes.
But here we have like, I think it's 60 frames per second, and it happens to like change if you do this at a line or you move to Requestanimationframe. But if it's like on not in the browser, then your frame rate might be limited. So this means that people with a higher frame rate get more sampling.
Yes. So older games usually had these kinds of problems when you. Does anybody remember the turbo button on computers? So that's the reason they had it, because the time step was fixed, and now when they started running on newer computers, the game loop went too fast. So this is when you leave the time delta out completely. So, yes, usually the dampening doesn't have that big impact, but it still has an impact. So
it's not like in Counter Strike with the whole power from the computer and slower.
No, it's
Or slow down faster.
for multiplayer games. You will have kind of you have the server coordinate everything anyway, so you don't get this distortion, or what do you mean? But yes, you should use here this thing. I hope I remember it in the right order. I cannot remember whether maybe it was this way or kind of like this way. It's like one-off error, but like using the powers. So it's something like this. Anyways, now the cleanup phase. One of those things that we did here is that we start having lots of these vectors now. So this means we need a vector. So let's make one. Should be pretty. No. So this will this be, and this y plus dy, and subtraction. What do we need those? Let's implement length. This will probably need this as well. So if you wonder why do you need Pythagoras theorem, this is the reason. If you want to implement your own vector. I think it's fine for now. And then we need here this. Now instead of xy we have position vector, let's say 10. And instead of velocity, let's put some more descriptive names here. No. That was too much. And it's working. Except now we want to actually use the methods. But here we don't have this, like with the scalar addition, we probably want to add this. So, I don't know. Let's call it that scalar. So we can do this. And then we can do this plus add this velocity line. Here we need to now do this element-wise multiplication. So we will add this as well here. Okay. Yes.
Whether return an 8 and return a new vector, couldn't you change that already existing?
Yes. And these are kind of really tiny differences in game engines that start to add up eventually. So you could do it multiple ways. And you are starting to pick trade-offs between like reusing objects in JavaScript, where it's probably useful, whereas in C you would more likely want to return because the compiler can optimize things much better than. So
how would the compiler like help with this? I mean, you're still asking
no, not necessarily. If the compiler can figure out, like I can now like smush these operations together, then it might not even like call a function.
But it still asks for
No.
Like not a new vector also.
No.
The return value to compiler sometimes does not copy.
Yeah.
I mean, like in the methods up there, it creates like return a new vector. So what the write this in
Oh yeah, here it does. Yes, here it probably makes a new vector, although I cannot be sure because V8, the JavaScript compiler, does pretty awesome stuff under the hood. So it might not actually allocate memory here.
If I have like hundreds of objects and all of their updates include like creation of 5 new vectors,
Yeah.
Like those process, the garbage collection has been
Yes, but it might not allocate memory here. It depends on the whatever runtime you have. So I'm not going to worry about it because it's easier for me here to just return it than to kind of have accidental reuse bugs. One of those things I wanted to do here is that instead of this speed here, I probably want to not directly modify this velocity here. So I will create a new vector here. No. And here I shall say let's do it this way. One of those mistakes that people tend to make is instead of if, they use else if here. Why is that wrong? Yeah, so when you hold up and down together, then you might get bizarre results. So, and now we can update the velocity here, but with this direction, and we have the speed times delta time. And yeah, okay. Now, one of those things that we probably want to do is to add some enemies or something moving on the screen that we can eventually shoot. So let's make an enemy. And yeah. So is there any questions about the physics stuff? It's kind of works. And now we will add this enemy here. And enemy just moves. And we probably don't want to dampen the enemy velocity, otherwise it's kind of boring when it stands still. And I don't know, let's use a circle for it. XY, then radius. Let's do this. Radius and start angle, end angle, and something. And direction not defined, so okay, we don't have this. So we have something moving here. And now we probably don't want it to move off screen. Let's make it move faster. First of all, I don't know. And then when we, let's say, if we hit the right edge, screen with, and we shall wrap it to the other side. And same. So we are going to do this. Has anybody implemented this part already? knows what's going on here. So we want to like always to get this enemy wrapping back into the game field. So let's do it this way, and just to make it interesting, let's add some random to it. So now it kind of starts wrapping somewhere. Now's the question that we probably want to have multiple enemies, and we probably don't want it to be the same color as the player, but so this means that we now have to kind of, instead of one instance, we need multiple instances, which means that we need to convert this into a class. We don't have to, because there are other ways as well. So let's do this way, and we can convert these. This. Is here, and now we need to create one enemy as well. Okay, and we probably want tons of enemies. So let's make tons of enemies, copy pasting it everywhere. This enemy game. So now we have two of them. What we probably actually want is a collection of them. So, and we start to notice here this repetition, which is quite similar for both of our game thingies there. So instead we shall make a list where entities, okay, list of things where we shall put the player, and let's put a new enemy, and I don't know, let's do it this way. And now instead of calling for each of those, we can do here a for loop over those things. And we can get rid of this, and now we should have a bunch of them. And we probably want to make this player as a class as well, so that way it's more consistent in the overall structure. Otherwise we will start to get different looking things, which is a little bit more annoying to deal with. Player is not defined. No. So here we can do now new player. So And of course, instead of, because here we are passing in the keyboard as a global argument, we probably want to get rid of this as well. So we can use input here, this input equals input. And let's use here this input and say that the player use keyboard as their input device. And okay. Let's make a circle for the player as well, so we can see where it actually is more easily. I don't know, this radius, let's say 5. And this. So now we have some. Okay. We have some enemies and the player, but we also want the player to blow up at some point. Also because when we want the player to blow up, we want it to not collide immediately with an enemy. So we probably want to somehow set the positions here a little bit better. And for that I'll implement a simple function which is random range, because I will be using this treble. So this means I can write here, let's say the enemy position is from 0 to screen width to screen height, and its speed is, let's say, minus 50 to 50, and so now we get some more interesting behavior. And we probably, let's put the player in the center of the screen as well. Okay. So, we probably want to shoot bullets or something as well. So, first, let's see if the player is colliding with something. So we can now do this in multiple ways. We can have a separate thing that checks for collisions, or we can have the player check itself against all the other enemies in the or things in the scene. I'm probably going for the first part, which means that I'm just going to loop over all the things in the world. We obviously don't want to collide with ourselves, and how do we detect circle and circle collision? This is one of those easier questions that we just measure the distance between them, and when their like radiuses add up, you can. So circle to circle collision is, let's say I have two circles and two cases. Here we know that these have these radiuses, and if they collide, then the distance between, like this distance, is smaller than the sum of the radii of the circles. So, kind of a quick way to implement collisions for circles. Well, collision detection. Position when this length is smaller than the other radius plus this radius, probably, and if this distance, then let's say the player is killed. Or do we want to say alive is false? Those hard decisions. I need to do it this way. And obviously we want to show that though the enemies are alive as well. So, oh no, entities is not defined. So this means I need to move these upwards somewhere. Oh, let's also do one thing. Let's lift out the vector implementation. And vector here as well. And okay, now we have this problem that player is not defined. This is getting annoying. Okay, let's put it this way. Entities is not defined.
Typo.
Yes. Entities. Okay. And okay, for now let's say if it's alive, then it's, I don't know, when it's live it's blue, and when it's not alive then it's red. So now we can see that we actually get killed, but we actually want to get rid of ourselves from the game field as well. So what we can do is here say, I don't know, let's do it this way. I never can remember in which order they must be. And we died. So now we want to shoot. But before that, we have this free floating thing here, entities. So instead of letting it be a global thing, we shall create something that represents our world. And this means that we can say that this entities is in the world, and instead of now modifying the entities directly, we can have functions such as spawn entity. Is push entity, and now we can also bring in the update loop here, so we can update and render. Does anybody have jokes, Andres? Does anybody have jokes?
What does the fart sound like?
Funny?
Yes.
Close enough. I was thinking of lightening the mood, but no, everybody's so serious. So world spawn, and now we need to move all of this somewhere else. So here we want to say that update the world and world render to context. And we can put it somewhere. In rendering, first clear the screen. And here let's say, okay, this entity is for each. Let's use the newer syntax because this way, and then you can hear this. And one of those things you might notice that I most of the time I'm making really small changes, and this is quite important. Otherwise, I will just go insane trying to figure out how things should fit together. So here we do update all the time, and we should have it still running. Kill me, kill me! No. What's wrong with you? Oh, we have this global variable still here. So we don't have anything to check against. So here, now we need to start binding our ancient entities and worlds together. So here, let's do it this way. Entity world equals this. So we can now access the entity, the world from this entity itself. And just to be clear, let's put these here as well. And right here we wanted this world entities for each, and entity this, and return. So now we should be able to kill ourselves. This game is called Suicide. Now, I think we can now add bullets as well. But for this, let's use this as our starting point, this enemy. Bullet. We have bullet. The position we probably want to pass in as an argument because that's where the player shoots it from, and velocity. So position, velocity, or I think direction is probably more correct. And the radius is probably something tiny. And for bullets, instead of going off, instead of wrapping around, let's kill them. So we can this alive if it's false. And let's make them, I don't know. So now we also need some button to shoot with. And so we need a new button, let's say space. I have no clue what the space code is. 32, magic number. in the player, we can now say that, oh, did we press a button? This input pressed space. In that case, this world entities spawn a new bullet from our current position and with the direction that we are like moving towards. And so we can we blew up something. Oh, this world, and we very efficiently killed ourselves. So we need to now add something to detect what should collide with something else. So we can make a few constants here. Let's say player is 1. Then enemy is, I don't know, 2, and the bullet is something like this. So these are kind of why are let's do it this way. It's probably clearer. So they are powers of 2. Then we can use bit masks to check them, but for now we probably don't need them. So the player needs to check that this let's call it tag. This is a player. I of course could use instance of or something like that to check whether it's the thing that I want. But with tags I can add multiple enemies and I don't have to check for each of them separately. And there are of course other solutions here as well. And here I check this tag. When it's not an enemy, then we just skip it, and we should be able to lay an egg. Lay multiple eggs. Something is... Why aren't the things moving? I don't know. This velocity... I'm still... let's multiply it with, I don't know, 100. And I can shoot. And I probably want to hit the things as well. Where are our enemies? And tag enemy, and we want to check for bullet. And if we hit the bullet, then we are dead. Enemy. This tag, not bullet, and can we die? We cannot die. Okay. We want to check thing that we are checking against. So this way. So now we can shoot stuff. Although the arrow is quite confusing right now. So instead of like pointing in the direction that we are moving, we probably want to show in the direction that we are actually shooting. And let's do, I don't know, this. And this is large, I don't know, some number, then we update our direction. And this direction. So that way, oh, I wanted to throw the arrow in that direction. Direction, let's say for, I don't know, 10. So now we can kind of, we have some kind of game already. Any questions so far?
I'm wondering what the memory consumption is.
4.4 megabytes.
Okay, what if you shoot?
Oh, I can do this. Let's do. Where did it go? Right here. So you can see this number here. So it's like some numbers, but it doesn't like keep increasing. So, anyways. Now we already have kind of a functional game. What we now want to do is to make it composable. Because when you see that we are starting to repeat a lot of code, for example, here we have this rendering code repeated, and then we have this update. Well, it's not repeated, but when we want to use, let's say, 2 players and they want to use different sprites and kind of. So effectively, the problem we are facing is that this issue that we are kind of like making these big blobs of things that do something in our game engine. So what we would like it to be is that, oh yeah, we have a player that is like these 3 things here. Like it has, I don't know, some information where it is, how it's rendered, and kind of stuff. So what we reach is kind of one of those things that most game engines use. Well, the how to say, the customizable game engines, effectively, is entity component systems architecture. So instead of saying that we have something called a player, we shall have something called an entity. And let's say for now there are different ways of implementing this, but one of the easiest is to say that, oh yeah, it has some common attributes. For example, in Unity you have all the things have a transform attached to it. So we can say that, oh yeah, it always will have a, I don't know, some position, and that's about it. And we shall also add components here. So we can have, let's say, instead of saying that, oh yeah, this player is like this big bunch of things, we shall separate these into components, which is like, let's say it's some image or texture, and we have this player movement logic, and then we have this collision logic. So here we can do it in quite a lot of ways, but for now let's do it name equals component. I'm going to do it this way. Depending on the engines, this approach differs. It could be a list, it could be some kind of something completely different. But effectively we have something that represents a thing in the world, and then we have added here some piece of functionality. So how do we now redo our thing? Oh, let's add alive here as well, and world. And let's do it this. Let's not put it as a parameter. Okay. So this means that one of the important things is being able to slowly migrate from one state of your program to another. So we don't want to now go refactor everything at once. We want to step by step start replacing different things. But what does it mean? Is that instead of saying that, oh yeah, this has, we start accessing this component directly, we will have here, for now, we will have here a render function and update function. We will later remove them. So, and here we shall look at the component, let's say, do we have something that updates itself? I don't know. Let's call it logic. I don't know. Doesn't matter. And logic up. And if we have such a component attached to ourselves, we shall call it. Of course, we could do it other ways as well. So. And we shall, and here we probably want to call it system, I don't know, which part of, and render to context. And now we would want to move all of this player into, like, split, make it into multiple things. So we need to now implement some kind of components that represent our state. First thing that we might need is something to render itself. So we can render. So let's say we have class, I don't know, circle for now. So we can, I think, implementing bullet as an entity is probably the easiest at this point. So we have render circle, and we have, let's say, what do we need for this circle to render? We probably want some color here, and that's about it, I think. I think radius we probably want to currently put into the entity itself, because it makes our lives easier to assume that everything in the world has a radius for now. Because we want to separate, well, okay, let's put the radius in the render as well, so we can see what will happen. So, radius. And now we want to have a render function, and we want to say that, oh yeah, this is the thing that can do rendering. Okay, yeah, I was right now thinking of that approach. So let's do that. Components, and this components push component. And we probably want to make sure that the component can access the entity itself. We can also add it as a parameter, but it probably doesn't matter as with many things. For each component, if component has update, then let's call the update. And here then, if it has a render, then let's call it render. And now for the rendering itself, I think this was a circle, or let's call it circle texture, just to be cool. We don't need this, and we need this color, and this entity position, and this should be now working. And now we probably want to make this a bit easier here. Let's pass it in as a list already. So now we can do something like, where is our setup code? We can use world spawn new entity, and let's say new circle texture, with color red, and what was the radius, and it crashed. So this means we messed up somewhere. This entity, oh right, I actually need to do here components for each component, this add component, which is somewhat better, except I need empty string. I have. Oh, it's here. Can you see it in the corner? Red dot. So we have our first entity. Now we probably want to add physics to it. So we can, let's say it's a circle body. We have these all properties. We have position, initial velocity, and some radius. And we have an update logic for it. Where was it? Let's say circle body, update delta time. This position equals this position adds this velocity times delta time. And for velocity, the same thing. Except now is the question, what goes here? Because we want to at some point update the velocity and also update the position. And here we need now a force that will be updated. Okay. And we can, I guess we can try it already. So we can do here new circle body. That was the order. Oh, I want. I really hate typing new vector. Just to have a shorthand for all the new vector stuff. So. No, and it was here, this velocity, this position, because I didn't get, let's say, position is, I don't know, 100 by 100, velocity is, I don't know, 50 by 50, and then the last argument was radius. So, it's over here, but it's not updating itself. Why it's not updating?
Because the position was in the entity as well.
Yes. So we probably actually want to move this position away from here. And we need to, in the rendering, we need to now find the updater somehow, or we need to find the physics body that has the position.
Why? I mean, couldn't we keep the position in the entity, but in the physics body based position there?
One thing we can actually do is instead is to do here this entity position equals this position. Because the physics system starts to like manipulate all those physics positions, velocities, and all together. So you don't want to mix in the rendering at the same time. So you can instead temporarily do all the calculations in the physics and then copy into the actual entity later. You can do it the other way as well, just directly modifying the entity position. So I know we can do it. Yeah. Let's do it this way for now. So we can see now it moves here. And okay. So where was it? Circle body. One of those things that we now would want to do is to add some behavior that says that when it goes off screen then kill it, or the other way that when it goes off screen then wrap it. So here what we can now do is to say that kill off screen component, which just has nothing, and it checks if this entity position. Wait, I have this logic somewhere. So the position, and if we are off screen, then this dot entity should die. And we can add this logic here, kill off screen, which of course doesn't show anything, because if it goes off screen we don't see it anyways. But we can look at the entities list, see that we have 5 items here, but initially we had 1, 2, 3, we have the enemies only left. Mm. So, and now we want to pass in the entity arguments as well. Let's say there's starting position. Let's do it this way. So we can, it's a bullet, and that's about it for the common attributes. Or actually, I think we can, oh, I know what I can do. We shall make a function called spawn bullet. And world, starting position, and what did we need additionally? Position direction. So direction. So we can say that we have a bullet, a new entity where we have things such as these behaviors. And we shall have this tag bullet attached to it, and the initial position will be set from the from here. And we can now put this away, and or I think we can. This is probably neater. And here, let's search for the spawn. Spawn, create bullet, this position, this direction. And almost. What went wrong? This circle body. Oh, right. Here we need direction multiplied by 100, let's say. So now we can actually delete this bullet class, and we have a reusable thing that we can use. So why aren't the enemies dying? Oh, right. The radius isn't here anymore. It's attached into the circle body. So we now need to access this body there, but before that we probably need to update all the other entities as well. I think we can. Okay. Let's make the enemy. For the enemy, we needed this wrapping function instead of killing. Wrap off screen, and we can do this wrapping here this way. Oh, we can test the wrap off screen function here. see whether, yeah, it works. So, and we also needed this special logic that it gets killed by the bullet as well. So we can for now use class killed by constructor tag this tag, and we say that here killed by here we shall check whether our position, this entity position, and this entity world entities. And we need to get to this radius somehow. And here as well. So what we would like to do here is to say that, oh yeah, component, let's say, body. Let's say I want to say that, oh, find me this circle body here. So here we can do this additional function. And here and if this components instance of component class return. Of course, this will break when we try to add multiple physics bodies to a single component, but I think that's fine for now. What? This? Oh, right. Thank you. Somebody's still alive. And so we want to find our component here, and we want to find the other this entity and component circle body. If it's missing, then I don't know. We don't have anything to do here. It shouldn't be missing, but well, stuff happens. So we have other radius, body radius, and this entity alive, and this position. This, okay, let's say position, and this is the other entity position, body radius, and it probably is, no, this is this one. So killed by tag, and we need to, where did we want to go? Oh, screen. Oh, now we can implement enemy. Create enemy. Because for the enemy we use random positions, we don't need to give those as parameters. You know, it's wrap of screen, new killed by bullet, and we can now say that though this tag is and this is an enemy now. The position is this, and let's do velocity here. use velocity. Radius is 10. So create enemy. We have position, return enemy. And now we should be able to do this. Now let's make it black. And we can and they die. So, which means that now we can remove this here. What else? Oh, we still have the player. Player, we know we have this additional arrow thingy there. So we have circle body, circle texture. Let's add, I don't know, player texture. Which can be then, I don't know, we can pretty much, I guess, copy it verbatim. Or we can actually, I think, let's stack them for fun. This probably doesn't make sense anymore. Color, radius, arrow. Here we need the actual entity position, and here we need the direction from somewhere. So we need also the player controller. Instructor input. This input equals input and update. We need somewhere to store the direction, and we need this logic into there. I think that's about it. This input, this direction, this velocity. Oh, now we don't have the velocity. We need to get the velocity from the circle body. So we can use body, and it's this. Oh, here we have the speed constant as well. We have this body that we add the velocity into, and entity has the world spawn, create call at this position. Okay, entity position, this direction. We have player controller, we have some sort of player texture. So, do we have everything for the player? Everything? I think so. So we can. It's the same.
The bullet.
Oh, yeah, this should be this tag. This way. And where? Oh, here. Create enemy function. Create player. Let's say we have this input. Radius is 10. Velocity starts at 0. Position is at screen width by due screen height by 2. And tag player killed by enemy. Let's say it wraps off screen as well. Velocity is 0. Put it there. Radius, we are blue, and we wanted to have a player controller input as well. And so we now, let's see what happens when we do this thing, create player. It exploded, which is, and I also wanted to add the player texture as well. Here, additional, no, that's the enemy. And player texture, no, let's do it this way. Cannot treat player texture render 2 of 3. Where is this? Oh, we want the player, this entity, find component, player controller, player direction, and player this radius, and okay. And now we can get rid of this huge player thing as well. So, and now the only thing left to do is to wait for the computer to catch up. We have engine.js, and what is the engine part here? It's testing. This we can, let's say, put this random thing here. Then the world thingy we can put in the engine, and we can make a separate file for the components. I don't know, the common stuff that everybody wants to use. So these things, and now we can do engine and components, and did we forget to save something? And now we have an engine with some reusable parts, some which are here. And that's how an engine is made. Questions?
How many engines have you written?
A few, like 4, 5, 6. I lost count.
What's the next step?
You repeat the same thing. You start adding, for example, sound system. You might add, you might extract physics properly into, let's say, instead of calling here, here instead of doing this, you might add something like some system that does physics system with some function delta time, and it does this updating properly and does pairwise collisions, for example. Or you might implement like proper circle collisions, and effectively you start adding stuff until you get bored. But the main thing I wanted you to see that it's step by step. It's when you kind of takes really small steps, it's not hard. It just takes tons of steps to like make something. So yeah.
Will you upload the final code?
Oh yes, yeah, definitely. And yeah, that's it.